Welcome to Study Session 3, MIC 300. Study Session 3 will be talking about immunity and immunodeficiency. Introduction. When confronted with infectious agents, the human body responds with various kinds of resistance. A primary form of resistance is the immune system. The natural resistance present in the body can usually confine microorganisms to the surface of the body and prevent entry into the innermost tissues and organs. Learning outcomes for study session 3. At the end of this study session, you should have learned the following. Firstly, specificity of the immune response. Secondly, immunodeficiency. Thirdly, congenital immunodeficiencies. Lastly, acquired immune deficiencies. Specificity of immune response. Cell-mediated immunity and antibody are both highly specific for the invading organism. The process by which these host defenses originate can be summarized by 3 actions, which is illustrated in the figure below. Antigens are substances that stimulate a specific immune response, resulting in the production of antibodies or activated cells. Antigens are usually foreign to the host organism, but in certain cases, they may be of host own substance that have been interpreted as being foreign. The word immunogen is synonymous with antigen. Antigens are large molecules of protein or polysaccharides. Immunodeficiency. There are several disorders traced to deficiencies of the immune system or dysfunction of the system. Immune deficiencies develop because something is lacking in the immune system. Dysfunction come about because actions of the immune system are deleterious to the body. Immunodeficiency occur in any of the 4 major components of the immune system. The figure below shows major components of the immune system. Congenital immunodeficiencies, B-cell deficiencies, and X-linked hypogammaglobulinemia, that is, Bruton's A gammaglobulinemia. This is very low levels of immunoglobulins, immunoglobulin G, immunoglobulin A, immunoglobulin M, immunoglobulin D, and immunoglobulin E. A virtual absence of B cells is found in young boys. Females carriers are immunologically normal. Pre-B cells are present, but they fail to differentiate into B cells. Selective immunoglobulin deficiency. Firstly, immunoglobulin A deficiency is the most common of these. Immunoglobulin G and immunoglobulin M deficiencies are rarer. Secondly, T cells deficiencies. Thymic aplasia, that is, Sjogren's syndrome. Both the thymus and the parathyroids fail to develop properly, which may lead to or cause chronic mucocutaneous candidiasis. Third point, hyperimmunoglobulin M syndrome. And lastly, interleukin 12 receptor deficiency. Combined B cells and T cells deficiency. Number 1, severe combined immunodeficiencies disease, that is SCID. Number 2, Wiskott, that is Aldrich syndrome. Number 3, ataxia, which is telangiectasia. Number 4, complement deficiencies. Number 5, hereditary angioedema. Number 6, recurrent infections due to C1, C3, or C5, or C6, C7, or C8 deficiencies. Number 7, autoimmune disease. Number 8, paroxysmal nocturnal hemoglobinuria. Phagocyte deficiencies. Number 1, chronic granulomatosis disease, that is CGD. Number 2, cardiac Igeshic syndrome, Jobs syndrome, leukocyte adhesion deficiency syndrome. Number 5, cyclic neutropenia. Number 6, myeloperoxidase deficiency. Number 7, interferon gamma receptor deficiency. Acquired immunodeficiencies. B cell deficiency can be differentiated in two. Firstly, common variable hypogammaglobulinemia and malnutrition. T cells deficiency can be also in two forms. Acquired immunodeficiency syndrome. This is caused by infection with the retrovirus immune. Take a 2. This is caused by infection with the retrovirus human immunodeficiency virus. This virus specifically infects and kills cells bearing the CD4 protein as a surface receptor. Secondly, also measles. Complement deficiencies can also be in two forms. Firstly, liver failure, which is caused by alcoholic cirrhosis or by chronic hepatitis B or hepatitis C, can reduce the synthesis of complement proteins by the liver to a level that is severe pyogenic infections can occur. Secondly, malnutrition, which is reduced supply of amino acid. Phagocyte deficiency can also be in two forms. Firstly, neutropenia. Secondly, chronic fatigue syndrome, that is chronic fatigue immune dysfunction syndrome. Summary of study session 3. In this study session, you've learned that firstly, specificity of immune response. Cell-mediated immunity and antibody are both highly specific for the invading organism. Then 2, immunodeficiency. There are several disorders traced to deficiencies of the immune system or dysfunction of the system. Then number 3, congenital immunodeficiencies, which can be B cell deficiency or X-linked hypogammaglobulinemia, that is Bruton A gammaglobulinemia. Immunodeficiency refers to some kind of deficiency in the immune system, and this can involve any component of the immune system. Thank you. We've come to the end of study session 3.